Imagine drifting alone through the endless darkness of space. There is no sound, no wind, no horizon. Only billions of distant stars shining across the universe. Everything feels peaceful. Then, something impossible appears before you. Far ahead, the stars begin to disappear. Not because something blocks them, but because space itself seems to have vanished. A perfect circle of darkness hangs silently in front of you. Around it, a brilliant ring of superheated gas spins at incredible speed, glowing brighter than millions of stars before disappearing forever into the blackness. You are looking at one of the most mysterious objects in the universe. A black hole. For decades, black holes have fascinated scientists and inspired countless movies. Many people imagine them as giant cosmic vacuum cleaners that pull everything toward them. But that isn't how they work. In fact, if our sun were suddenly replaced by a black hole with exactly the same mass, Earth would continue orbiting almost exactly as it does today. We wouldn't immediately fall into it. Instead, the sky would simply become dark. Without sunlight, our planet would slowly freeze. This reveals one of the biggest misunderstandings about black holes. Their danger doesn't come from having magical gravity. Their danger comes from an unbelievable amount of mass being squeezed into an incredibly small space. More than 100 years ago, Albert Einstein changed the way we understand gravity forever. According to his theory, gravity is not an invisible force pulling objects together. Instead, massive objects bend the fabric of space and time itself. The more mass an object has, the deeper that curve becomes. A black hole is where that curve becomes so extreme that every possible path leads inward. At its edge lies an invisible boundary known as the event horizon. This is the point of no return. It has no surface, no warning signs. You cannot see it. You cannot touch it. But once you cross it, escaping becomes impossible. Not even light can find its way back. That is why black holes appear completely black. They trap light itself. Now imagine that you are inside a spacecraft slowly approaching the event horizon. Everything around you feels completely normal. Your heart is beating. Your watch is ticking. Nothing seems different. But far away, another astronaut watches your journey. To them, something extraordinary begins to happen. Your spacecraft appears to slow down. Second by second. You move more slowly. The light from your ship becomes dimmer and redder as gravity stretches every wave of light trying to escape. Eventually, you seem almost frozen in place. From your friend's point of view, you never actually reach the event horizon. You simply fade into darkness. Yet inside your spacecraft, you notice nothing unusual. Your watch still counts every second. Your heartbeat remains steady. You continue moving forward. How can both observations be true? The answer is one of the strangest discoveries in modern physics. Near a black hole, time itself no longer flows the same way for everyone. The closer you get, the more reality begins to change. Distance loses its meaning. Time stretches. The universe starts behaving in ways that seem impossible. And then, you finally arrive at the edge of the event horizon. One more step, and there is no way back. You take a deep breath. You move forward. And for the first time in human history, someone crosses the point of no return. But crossing the event horizon is only the beginning.
You take one final look behind you. The stars are still there, shining peacefully across the universe, but with every passing second they seem farther away. Ahead lies only darkness. There are no alarms inside your spacecraft, no violent shaking, and no sudden explosion. If you didn't know you were approaching a black hole, you might believe nothing unusual was happening at all. From your perspective, everything feels completely normal. Your heartbeat remains steady, your breathing is calm, and every second on your watch passes exactly as expected. But millions of kilometers away, the astronaut watching your journey sees an entirely different reality. To them, your spacecraft slows almost to a stop, as though time itself is refusing to let you move any farther. This strange effect is known as gravitational time dilation, one of Albert Einstein's most astonishing predictions. The stronger gravity becomes, the more slowly time passes compared to someone farther away. Near a black hole, this effect becomes so extreme that two people can witness the same event and experience completely different versions of time, with both observations being perfectly correct. As you continue your descent, another strange phenomenon appears. The light from the distant stars begins changing. Some stars seem brighter than ever, while others slowly fade from view. The black hole's immense gravity bends the paths of light itself, creating a distorted view of the universe unlike anything human eyes were ever meant to see. Looking forward, the darkness seems endless. Looking behind, the universe appears stretched and warped into a glowing ring surrounding the black hole. Space itself no longer behaves the way you have always known. Up and down lose their meaning, and every direction seems to point toward the darkness ahead. Then, without any warning, you cross the event horizon. Nothing happens. There is no invisible wall, no flash of light, no sudden feeling of being trapped. If the black hole is large enough, you might not even realize the moment you cross the boundary that no object, not even light, can ever escape again. But while you notice almost nothing, the rest of the universe has already lost you forever. No message you send will ever reach your friends. No signal can travel back across the event horizon. To everyone outside, your story ends here. It is as though you have vanished from existence itself. Inside the black hole, however, your journey continues. Gravity grows stronger with every passing second, pulling far more intensely on your feet than on your head. At first, the difference is tiny, almost impossible to notice. But as you fall deeper, those forces increase dramatically. Scientists call these tidal forces. They are responsible for one of the most terrifying processes in the universe. Your body is slowly stretched by gravity, not because gravity is simply strong, but because it is much stronger at one end of your body than the other. For a supermassive black hole, this stretching might not begin immediately. You could continue falling for several minutes before noticing anything unusual. But eventually, there is no escaping what comes next. Every second carries you closer to the center, where the laws of physics begin to break apart. Everything humanity understands about space, time, and matter is about to be pushed beyond its limits. And somewhere in the darkness ahead lies the greatest mystery of all. Every second pulls you deeper into the black hole, and the force of gravity becomes stronger than anything you have ever imagined. At first, the difference is almost impossible to notice. But as you continue falling, gravity pulls much harder on your feet than on your head. The result is one of the strangest and most terrifying effects predicted by physics. Scientists call this process spaghettification. Instead of crushing you instantly, gravity stretches your body longer and longer while squeezing it thinner and thinner. Every cell, every bone, and every atom is pulled apart by the enormous difference in gravity between the top and bottom of your body. Long before you reach the center, the human body could no longer survive these extreme conditions. Yet the greatest mystery is not what happens to your body. It is what happens to space and time themselves. According to Einstein's theory, every possible path inside the event horizon leads toward a single destination known as the Singularity. It is a place where gravity becomes infinitely powerful, and where our current understanding of physics simply breaks down. No telescope has ever seen a singularity, No spacecraft has ever sent back information from inside a black hole. Everything beyond the event horizon remains forever hidden from the rest of the universe. This is why black holes continue to challenge some of the greatest scientific minds in history. Some physicists believe the singularity is the true end of the journey, where matter is compressed beyond anything we can imagine. Others think our theories are incomplete, and that quantum physics may reveal an entirely different answer. There are even ideas suggesting that black holes could connect distant regions of space through mysterious tunnels known as wormholes. So far, however, no direct evidence has ever confirmed these extraordinary possibilities. One of the biggest mysteries in modern science is called the black hole information paradox. If everything that falls into a black hole disappears forever, what happens to the information it carries? According to quantum physics, information should never be completely destroyed. Yet black holes appear to do exactly that. Solving this paradox could completely change our understanding of the universe. Perhaps the most fascinating discovery is that black holes are not simply cosmic monsters destroying everything around them. They also help shape galaxies, influence the motion of billions of stars, and may even play a crucial role in the evolution of the universe itself. At the center of our own Milky Way lies a supermassive black hole, silently controlling the heart of our galaxy. So, what really happens if you fall into a black hole? The honest answer is that no one knows for certain. Science has uncovered many pieces of the puzzle, but the final moments beyond the event horizon remain one of the greatest mysteries humanity has ever faced. Perhaps future generations will finally discover the truth. Until then, black holes continue to remind us how much of the universe remains unexplored. If you enjoyed this journey into one of the universe's greatest mysteries, don't forget to leave a like and subscribe to Beyond Discovery for more amazing adventures through space, science, history, and the unknown. Thank you for watching, and we'll see you in the next adventure.